Math is great, math is okay. You will need in life every day. From pandas to functions to fractions.
So I'm just trying to copy the directions, paste. All right, there's my directions. Okay, so let's go ahead and get the cube root of that one. So here I have a equals 50. Okay. Now something I noticed before I even do this is that both of these numbers are what? Even or odds? Evens. So let's go ahead and take a GCF, greatest common factor. So I'm going to guess 2 times 27 times x cubed, and this one is going to be, whoa, all right, can't really zoom in, can I? All right, there we go. 2 times 64, did I get that right? 120, yeah, times y cubed. So what do they have in common? They have a 2. So the GCF is 2. And then we still have 27 x cubed minus 64 y to the third power. Okay, so why did I do that? My a value is going to be here, and my b value is going to be from here. Did you notice how I didn't circle the minus sign there? It's not a negative. Okay, so let's go ahead and find the a value. So we need to take the cube root. Let's break these up into factors, the same thing you did in greatest common factor. So this would be 3 times 3 times 3, x times x times x. Trying to find the cube root, and there are 3 of them to come out in the neighborhood, same exact, they can come out, that 3 is on the outside there. Same thing with these 3 x's, they can come out of the house into the scary neighborhood, but there's only one of them, right? So we have an answer of a equals 3 times x, or 3x. All right, let's go ahead and try this one. b equals 64y to the third power. And again, we need to take the cube root. So 64 can be broken down into 4 times 4 times 4, and y cubed is 4y's. And then there are 3 of them, so they can come out. 3 of them, they can come out, but it only looks like there is 1 of them, so that would be just 4y. 4y. Now, I'm gonna go ahead and circle this. Let me prove why this is correct. If you take 4y and you cube it, you would get 4y times 4y times 4y, right? And then 4 times 4 times 4 would give you 64, and then y times y times y would give you y to the third, which is our original problem. Okay, so we just found our a and our b value. Now let's go ahead and write down the formula that we're going to use. I noticed this is a minus, so I'm going to do a minus b cubed. And then I'm going to write out my a's and b's. ab, a squared, ab, b squared. And then I'm going to go back and remember it is a difference. So, soap. Same. Opposite. Always positive. Okay? All right. Let's now just do our substitutions, and then we're done. So we got the a and b value formula. Let's now substitute. Every a value would be 3x. And every b value is going to be 4y. Let's go ahead and get those in there. So my a value is 3x. Now again, I'm going to put that in a bracket. My b value is 4y. A value inside a bracket, 3x squared. Notice every substitution has the grouping symbol there. The a value is 3x. B value is 4y. And the b value is 4y. And don't forget the power of 2. All right, let's just go clean this up now. We have 3x minus 4y. And 3x squared times 3x is 9x squared. 3 times 4 is 12, and x times y is just xy. And then 4y times 4y is going to be 16y squared. Now, this is a common mistake for students, and I almost forgot about this. Let's use our red one. Remember our GCF of 2? I'm going to have to put that 2 back in. Super important. Let me go ahead and highlight this as our answer. Because if you multiplied all of this out, I'm not going to do all of it, but you know, you would do 3x minus 4y, and then you would take that part and do 9x squared times plus 12xy plus 16y squared, multiply those out, combine like terms, and then take all your answer, multiply it by 2, and you will get this in the red, or the original problem. You'll see a bunch of them cancel. Okay? Uh-oh. I see a mistake. Y to the 6. The original problem was y to the 6. My mistake. Let's see if we can. Okay, this would be 2, 2, 2. So this would be 4y squared. B would be 4y squared. Here, here, and here. Okay, how does that change my problem? So this would be 4y squared, and then y squared times y squared is y to the 4th power. Double check. And this one will be 4y squared. And that would make sense. Yes, that would work. Okay, so that is our answer. This is the sum and difference of cubes. Don't forget to use your soap. Hey guys, let's go ahead and factor this one. Now this one looks unique because it has 2 variables. But I noticed this has 2 terms. 1, 2 terms, and you have a minus sign, so this is called the difference of squares. And here's a quick way to solve it, and I'll do it a different way that most students would have done it. So difference of squares is if you take the square root of both of those, you'll have 2x on the left, and on the right side, square root of 9y squared is just 9y. And then you have 1 plus, you have 1 minus, and then this is your answer. Okay, most students aren't going to solve it that way, so you can try something like this. I'm going to split them apart, and I want to make it a trinomial. So what I'm going to do here is I'm going to add something. I'm going to add a plus 0xy. Now you can imagine if it just was like 4x squared minus 9 without the y squared. So we're going to do the same thing. We're going to put it into an x and then a box. And then I think you'll see that it's the same. Okay, A, B, C. So A times C is negative 36. My B value is 0. The two numbers that multiply are going to be 6 and negative 6. Those add to be 0. So these are going to go in here. And remember, you are splitting a xy. So you have a positive 6y and a negative 6y. Okay. A term always goes in the top. The other term goes there in the bottom. So I'm going to have 2x and 2x. Then on the top there, 2x times something. This will be, pay attention, negative 3y. This one will become a positive 3y. There in green is the same thing that I have over here. Okay, a little bit tricky with two variables, but I think two ways you can get it. Alright, in this problem, I asked you to factor, so I'm going to show you guys that chunking method. I'm just basically going to be looking at the first two to see if they have a GCF. You guys told me the GCF is what? 5x. So this can be written as, think about it, 5x squared minus 2 times 5x minus 24. Okay. And then there's my substitution, right? Every time I see 5x, we can write which variable? So I have z squared minus 2 times z minus 24. And then you can just factor this. A times c is negative 24. Your b value is negative 2. What are the two numbers? Negative and so now I can write z minus 6, z plus 4. Are we done? No, we gotta do the substitution again. Z is equal to what? 5x minus 6, and what do you write here? Z, Mr. Moon. 5x plus 4. Raise your hand if you got that. Alright, let's do the X box. It's not going to be fun because I can look ahead. Like, those numbers are really big, right? A, B, and C. A times C. How much? Negative 600? That's right. Is that right? And B value is negative 10. Ooh. Where are our two numbers? Negative 30 and 20. These two multiply to be negative 600. Those add to a negative 10. If you're just barely grasping this X in this box method, just keep doing it. X in the box, X in the box. Negative 30x, 20x. What am I going to put in there? 25x squared. What am I going to put in here? Negative 24. So if you don't know what to put in there, make sure you have on your formula sheet, and I'm going to give you like a really big like chart to help you understand which kind of factoring to do. But for right now, you just know do greatest common factor and then the X box, right? Cross what's your GCF here? 5x. And this direction, 5x. GCF here, 4. Remember, if you don't see it, here's another way of rephrasing. 5x times something has to equal negative 30x. What's out here, class? And you can always double check your answer. Negative 6 times 4 is negative 24. So I have 5x minus 6 and 5x. That's a positive 4. Raise your hand if you got that as your answer. Question number 5 says use the sum and difference of cubes to factor each binomial over the set of real numbers. Remember, I'm just going to tell you to factor. How do you know when to use the sum and difference of cubes? There's a couple of reasons why. You only have a binomial, 2 terms. And then the second condition is if you added a placeholder, x to the third, plus 0x plus 125, half of 3 is 1.5. This is 1, so you cannot use the x box of factoring. So another way to know you're going to use this method is if you could take the cube root of each of these. There, x times x times x is x cubed, and 5 cubed gives me 125. This is my a, this is my b. I'm going to plug that into the formula. It's always going to be a squared, b squared. And then I'm going to use SOAP, same, opposite, always positive. I'm going to do my substitutions. My a is x. My b value is 5. There, this is x squared. This is going to be a minus. This is going to be x times 5, which is 5x. And my b value is 5, so this is going to be 25. How do you factor x cubed plus 125? You use the formula, and then this is your answer. Let's do the same thing for question number letter C. I'm going to see if I can find the cube root. Class, what number would go in here? X squared is correct. Remember, when in doubt, write it out. When in doubt, write it out. That's 3x squared, and remember x squared is just x times x. So there you have 6 x's. And the cube root of 8? 2. So in this problem, my a value is x squared, my b value is b. Now, in this problem, the negative sign is not negative 2. This here is just telling you how to do the SOAP. Let's fill it out. And this one I'm going to take a little bit longer to do because you have the x squared. So my SOAP, same, opposite, always positive. My a value, b value, a value squared, so that means x squared times x squared, which would be x to the 4th. A times b, so that would be x squared times 2, so that would be just 2x squared. And your b value is just going to be 2. 2 squared is 4. Always, in the sum and difference of cubes, the second part of the problem, the trinomial here, this is always prime. You can never factor that. It'll always be prime. So, do you have a, b, and c? If you made there be a placeholder, can you take half of it? If you can't, that means you can't do x box. And if you can take the cube root of both of those binomials, then you have a sum and difference of cubes problem. Alright, so I'm going to show you guys chunking or substitution by using this example here. 49x squared plus 35x plus 6. I first look at all of the numbers, the constants, and recognize that there's no greatest common factor. Then, this chunking or substitution method only works in a particular case. If I look at the first two, I have to think to myself, does it have anything in common? Class, does it have anything in common? Yeah, I can make that letter, we'll make it a z. Z is equal to 7x. So 49, I'm just going to rewrite the problem. 49x squared plus 35x plus 6. And now I can write 7 parentheses 7x squared plus 5 times 7x plus 6. Do you see that? There's my chunking or my substitution. Instead of writing 7x, I can write what variable now? Z. So let's write that. Z, I like to draw another line through it. Z squared plus 5 times z plus 6. And now can I use my Xbox factoring? Yeah. Two numbers that multiply to be 6. And two numbers that add to be 5. Class, what are those two numbers? 2 and 3. So I have z plus 2, z plus 3 that I got from my factor. And then we just finish up the problem by going back here. Instead of writing z, class, we can write what? 7x plus 2, 7x plus 3, and this is my answer. So I showed you guys factoring by using chunking or substitution, and now I'm going to show you guys how to factor the same problem using the Xbox method. In the Xbox method, I'm going to use A, B, and C. So if you have your calculators out, A times C, 49 times 6, will give us 294. And then my B value, which is how much? 35. I need to think of two numbers that multiply to be 294. But the same two numbers there will also add to be 35. Now, what can you do with such a large number? Well, in your calculator, you can do 294 divided by 2. If there's a remainder, that means it's not a factor. If I divide it by 3 or 4, 5, and you keep going and increasing those numbers. Well, you play around with it. You have the ability of your calculator. And then those two numbers are, anyone find them? 21 and 14. On your quiz or test, I won't give you such a large number. Let's go ahead and put this in a box now. I have 21, and I'm going to add x. And 14, I'm going to add x. And the reason why you add x is we're basically splitting the b term. In the top left will always go the a term, 49x squared. And the bottom right, what am I going to put, class? 6. That's always the c term. How do you get the numbers outside the box? What's our greatest common factor here, class? 7x. Greatest common factor here? 3. Greatest common factor this direction? Greatest common factor. And you can always multiply to check. 7x times 7x is 49x squared. 2 times 7x is 14x. 7x times 3 is 21x. 2 times 3 is 6. And then my answer is 7x plus 2. 7x plus 3. Class, did we get the same answer? Yeah. So
This one, you had to work with larger numbers. Again, in our examples later on, I won't give you such large numbers.
Missing formulas in life? Problems becoming too difficult to clear? Well then, you need Mr. Math Cleaning Solution. Just spray the liquid formula onto the mess, then wipe it clear, and enjoy the result. Mr. Math. Stay clean and calculated. Order now at www.gpproductions.com and get an additional